In this course that I've been teaching you, there are 3 different ways to solve a system of linear equations. The first one I showed you was graphing. The second one, which I'm getting ready to show you, is referred to as substitution. And the third one, which you'll see in an upcoming video, is called addition elimination. And there's a reason why we have a couple other ways to do it, because sometimes when you solve these equations, you may end up with a fractional x or y, and we can't really graph that. But if I did it through substitution or elimination, I would know what the answer is for where it crosses the x and the y intercept, but I don't have to graph it. So it comes in handy to be able to know each of these 3 ways. So as we do substitution, you see that we have 2 linear equations. In order to, I'll say, play substitution, you have to be given an equation set up as either x is equal to something or y is equal to something. So in this case, the author of the textbook that I'm using said that they're declaring that y is equal to 2x minus 4. So I'm going to circle this, and from now on, y will no longer be called y. I'm going to go right up here to that y, and when I get to that y, I'm not going to say 4y. I'm going to say 4 times his new name, which is 2x minus 4. That way I'll be able to solve for one variable and then substitute in and sub for the other one. So y used to be called y, but now his new name is 2x minus 4. When you see him in the other equation, call him that. So I'm going to begin writing the 3x. 3x minus 4, don't say y, here's his new name. 2x minus 4, I have an equal sign now, and then the number 1. Now it looks like we're going to need to do some distribution and combining like terms. So here we go. We have a 3x, a negative 4 times 2x is a negative 8x, a negative times a negative is a positive 16, and all that equals 1. But we still have some x's here that need to be combined before we move our number to the other side. So a positive 3 and a negative 8 is a negative 5. Negative 5x plus 16 equal 1. Looks like some equations we've done from the past, doesn't it? It's time to move the 16 to the other side. So I'm going to take away 16 to clear that out. I have a positive 1 and a negative 16. And over here I have a negative 5x equal negative 15. And a negative 5x equal negative 15, you know what's going to happen. Let me move it over here in case it gets too low. A negative 5x equal negative 15. Let's divide by the number of the variable, which is a negative 5. And 5 into 5, negative into a negative is a positive x. Negative into a negative is a positive 3. So through substitution, we found out that x was 3. So I think I'll do this. I'll put 3, comma, and I'll wait to see what y is. Okay, now I'm going to erase this information, and I'm going to sub in either of the equations I want what x is, and x is 3. All right? So I think I'll use the bottom one because it looks pretty easy to me. I'm going to say y equal, now here comes 2. Don't say x because we already know that x is 3. So let's go 2 times 3 minus 4. 2 times 3 is 6 minus 4. So y is 6 minus 4, and 6 minus 4 is 2. So the ordered pair, and the only ordered pair that will solve this system of equations, is going to be a 3, comma 2. So we know that these two lines are going to intersect at 3, comma 2. So we've solved the equation simply by subbing in the value or the new name of y and then go back and find what x is. Okay, let's try another one just like that. All right, let's try x plus 4y equals 9. And this time I'm going to say x is going to be equal to a negative 6 plus y. Now it's set up the way we want it because I do have an x that's by itself. X used to be called x. He's not x anymore. His new name is what? His new name is a negative 6 plus y. So when you see him right up here, I'm going to aim it to where we're going to sub in. He is no longer x. That is not his name. His name is negative 6 plus y. So let's write that. X, no. Negative 6 plus y, let's keep going, plus 4y equal 9. Once again, we've got some combining to do here. A negative 6, we have a positive 1 and a positive 4y. So that's a positive 5y equal 9. Now, I think it's time for the negative 6 to move to the other side with a positive 6. That will clear out. And a positive 6, I now have 5y is equal to 15. And if 5y is equal to 15, when I divide both sides by 5, y will be 3. So I'm going to go ahead and prepare the ordered pair. I'm going to go right here, and this time y is going to be 3. I'll wait to find out what the x is going to be in just a minute. Okay? All right, now I'm going to erase this, and we're going to sub in y is 3 on either equation. Okay? Okay, I think this time, this looks easy, though I can use either one of them. I don't know what x is, but I know that y is 3. So I'm going to start writing the equation. X plus 4, what's y? 3, equal 9. Well, x plus 12 equal 9. You know that the 12 has to go to the other side. You know equations. Take away 12, take away 12. We now have x is equal to a positive 9 and a negative 12 is a negative 3. So x is a negative 3. If we were to graph these two lines, the point of intersection would be at a negative 3, 3. So we don't have to graph it. If you want to know where it crosses, we have the answer through substitution. Okay? You don't get good at this till you practice, so I think we need to do another one. Okay. Okay, this one is a little interesting. I'm going to say y is equal to x plus 3 and y is equal to 2x. Now, as you can see, either one of these I could use because each of them say that y is equal to something. So I'm going to just pick the easiest one, the one that has the least amount of numbers. And I'm going to say if y's new name is 2x, then I'm going to circle that 2x and I'm going to aim it right up there where that y is. He's not y anymore. His name is 2x. So what's y? 2x. 2x is equal to x plus 3. Now you know we've got to get our x's together. So don't we need to move this over here by taking away an x, take away an x, 2x take away 1x is 1x is equal to 3. Okay, let me put that. X is equal to 3 and we're trying to find out what y is. Now we can go into either one of these. If x is 3, I think I'll just, I'll go up to this one. And when I get to x, I'm going to put 3. Okay, here we go. I'm going to say y is equal to, what's x? 3. 3 plus 3. Well, 3 plus 3 is 6. So y must be 6. And that's true. So in this particular case, these two equations, if you chose to graph them in slope-intercept form or however you want to graph them, we're going to end up crossing or intersecting at 3, 6. That's the only location that they will cross. All right, let's try another one. Maybe just one that's a little bit more difficult. Okay, let's try 3x minus 2y equal a negative 25. And then I'm going to say x equals 20 minus 5y. Now, that looks kind of difficult, but I think we can do it. We do have an x isolated, so x's new name is 20 minus 5y. That's his new name. So when you see x right there, Do not call him X. Call him 3 times his new name. All right, here we go. 3 times 20 minus 5y, close your parentheses. Now continue the statement. Minus 2y equal negative 25. It's time to distribute and then maybe combine some like terms. That is 60 minus 15y minus 2y equal negative 25. Okay? Now, it looks to me like we've got to do something with these y's here. So, it looks like we have 60, a negative and more negative is a negative 17y equal negative 25. Time to move the number to the other side so we can solve for y. Let's take away 60, and let's take away 60. We now have a negative 17y is equal to a whole bunch of negative, a negative 85. So if a negative 17y is equal to a negative 85, I believe 17 will go into both those numbers. Negative 17, negative 17. 17 to 17 is going to be a positive y. And 17 into 85, I believe, is going to be a positive 5 because 17 times 5 is 85. 2 negatives make a positive. So y is going to be equal to 5. Okay, let's write that down. If y is equal to 5, then we need to find out what x is. So how about I erase this, and we can choose whichever equation we like. And I rather like that bottom one. I don't know why, it just has less numbers. It doesn't look like the numbers are going to be too big. So I'm going to go, I don't know what x is, so I'm going to say x is equal to 20 minus 5. But what's y? 5. Okay, here we go. So we have x is equal to 20. Negative 5 times 5 is a minus 25. Now, you know that 20 minus 25 really means keep the first one, change it to addition, add the opposite. So we have more negative than we have positive. So in this case, x is going to be a negative 5. I now have my ordered pair. The only place these two lines will cross will be at a negative 5, 5. And that is the solution to this system. All right? Let's do one more, and then I think you have it pretty well under control. Okay, my last one is easy. You've seen one like this before. I'm going to say y is equal to 2x minus 6, and y is equal to 3x. Now, you know I'm going to take the easiest way out here. Though they're both convenient and ready, I'm going to pick the bottom one, y is 3x. Okay, if y's new name is 3x, then I'm going to aim up to the y, and when I start to write, I'm not going to say y, I'm going to say 3x. Here I go. 3x is equal to 2x minus 6. It's time to move the x's, get them on the same side. So I'm going to take away 2x to clear, and I'm going to take away 2x. I now have 1x left equal a negative 6. So we have solved for x. X is a negative 6. And we'll find out in just a minute what y is. All right, if x is a negative 6, I can go into either one of these. So I'm going to go easy again. I'm going to go with that y right there. Y is equal to 3 times what? Negative 6. So that must mean that y is equal to a negative 18. So the ordered pair for this system is negative 6, negative 18. Now, in this video, there was already an extra y set up for us. In the next lesson, we won't have an extra y set up solo for us, and we're going to have to isolate it ourselves and then begin to solve. But if you can do this, I think you'll enjoy doing the next one.